Good afternoon. We're going to look through a binomial expansion problem today. I think this is a particularly interesting problem because it's asking us to specify an individual term in a binomial expansion, which is a really common problem people have. Tendency to try and expand this fully and not identify the individual term. So we're going to focus today on how do we get an individual term out of this expansion so that we can find the coefficients the problem is asking. There's a little bit of background noise from someone playing violin in the room next door. So they're either very good at playing violin or this is a recording. Either way, hopefully not a copyright issue. So we have a binomial expansion. It's x cubed plus 2 over x to the power of 8. We're asked to write the number of terms in the expansion. This part is pretty straightforward. Every binomial expansion is going to have one more than a number of the power. So this is just 9. So that's an easy 1 mark. But the challenging part here is finding the coefficient of the term x to the 4. And a common mistake people are going to make here is trying to expand fully. There's 9 terms as we've established, so that's going to take a very long time if we try and find all of the terms. But this is quite difficult here to identify which term is actually going to be the x to the 4th. Another common problem people have is assuming that you're trying to take x cubed to the power of 4, which will give you x to the power of 12, and also you've got to deal with the fact that there's an x on the bottom of the fraction here. So there's actually a lot going on that makes it kind of difficult to figure out what power we're supposed to be looking for when we're trying to find the x to the 4 term. The easiest way, in my view, to approach problems like this is to start with a general term, simplify that, and then work from that general term to try and get an answer. So what would the general term look like here? Well, we've got our two components from the binomial. We've got our x cubed and also our 2 over x. These are both going to be raised to powers. And we know that the powers that go up here have to add up to the value of n, the power that we have over the binomial at the beginning. So to represent that, we're going to have just an r here and an 8 minus r here. So I don't actually know what those powers are going to be, but I know that we have them represented here. We've got the fact that they add up to 8. And then in front of this, we are going to have our binomial coefficient, which will be 8 choose r. It doesn't matter if you put 8 like r down here or 8 minus r, so long as it's one of the two powers that's at the very top of these two expansions. And then we can work through trying to simplify this general term, because this is going to work for any term in this binomial expansion, but we need to figure out which term is going to give us the power of 4. So we can use our exponent rules here and multiply the 3 and the r, and in this case, just raise the 2 and the x to 8 minus r. So that becomes, I don't know why I've drawn an 8, becomes x to the power of 3r multiplied by 2 to the power of 8 minus r over x 8 minus r. And then further, we can distribute this, again using our exponent rules, by adding together the relevant powers. Now, since this is on the bottom of the fraction, you can think about this as a negative exponent. So really, we should be subtracting 8 minus r from 3r, which is going to give us 3r minus 8 plus r. So we get sort of 4r minus 8 as our combined power over the x term. And then we're also going to have the 2, 8 minus r here, and I'm just going to leave 8cr, just like that. So what this means is we've got a representation of what the power is going to be in terms of r here, and if we can find a value for r, we can just plug it into the rest of this to get our full term. So we know that we want r to be 4, or we want our power to be 4. So we just come over here and do some simple algebra. 4r minus 8 equals 4. If we then go 4r equals 12, r is going to be 3. Once we've got our value of r as 3, we can then plug that back into the problem. So we're going to have 8 choose 3, x to the power of 12 minus 8, 2 to the power of 8 minus 3. And this is going to give us x to the power of 4, which is what we expect. And it's also going to give us 2 to the power of 5, and we're also going to get 8 choose 3. And really, for answering this problem, we've only been asked to find the coefficient of the x to the power 4 term. So we're mainly interested in this and this to find our solution. So 8 choose 3 times 2 to the power of 5. And if we can solve that, we'll have the answer to the problem. So you can do 8 choose 3 in a calculator, but just to show you how to do it by hand, in case you need to, because there are non-calculated problems where you do need to understand how this works. You can have 8 factorial over 5 factorial, 3 factorial. So you're picking your number at the bottom of C as one of the bases here, and the other number on the base is going to be 8 minus 5. So you're going to have 5 factorial and 3 factorial. And then to simplify, you're going 8 times 6, 7, 5 factorial. I'm going to stop at 5 because ultimately we're going to be able to cancel that with the 5 factorial down here. But I will expand the 3 and the 2 and the 1. So the 5 factorials will cancel. The 3 and the 2 cancel with the 6, and we get 56. That's our 8 choose 3. And then 2 to the 5th, so we're going to have 56 times 2 to the 5th, which is going to be 32. And if we multiply those together, we're going to get, we need to do this in the calculator, 56 times 32, 1,792. Just like that. And that would be our coefficient in front of the x to the power of the 4 term. So you don't have to do it in this exact way, but I find it's helpful to come up with a term that is generally useful for every individual term in the expansion. And then you can go and plug in values for R once you found it to get this kind of simplified term and then this term that's specific to our particular answer here. But this simplification also lets us solve the coefficient fairly quickly once we figured out which term we're